this is a review of the Edgenuity lesson, Factoring Polynomials Greatest Common Factor. So for example 1, it says find the greatest common factor for these three here. So when you're finding the greatest common factor, the first thing you have to do is just worry about the numbers. So what's the biggest number that I could divide out of 12 and 18 and keep it a whole number? That would be 6. 12 divided by 6 is 2, and 18 divided by 6 is 3. So we can divide out a 6 out of both of those. After you decide the number, then you look at the letters, or the variables. So this one is a to the first power. Remember, we don't write that 1 there. And then this one is a squared. So you can only take out the least amount. So since this one only has one a, that's all the more that we can take out. We can't take out a squared because this one only has 1. It doesn't have 2 to give. So I would take out 6a for those two. That would be the greatest common factor. Okay, so on the second one, again, start with looking at the numbers. So 4, 12, and 18. What's the biggest number that I could divide out of all three of those and they stay whole numbers? Be a2. They're all divisible by 2. And then looking at the letters, or the variables, this one has 1m, this one has 4, this one doesn't have any. So because this one doesn't have any, we can't divide out any of the m's because this one doesn't have any to give us. So the greatest common factor of these three is just 2. Okay, now let's look at the third one. So 60, 45, and 75. So the biggest number that we can divide out of those three and stay whole numbers would be 15. Okay, so now let's look at the x's. This one is x to the 4th, x to the 5th, and x cubed. So we know that they all have an x on there, so we know we're taking it out. But how many? The least amount is x cubed. So that's all we can take out because it has the least amount to give us. So x cubed. So now, looking at the y's, this one's y to the 7th, y to the 5th, and then just y. So that's y to the first power. So again, you can only take out the least amount. So this one here, y to the first, because that's all it has to give us. So for example 2, we're going to factor. And the way we do that is we decide what the greatest common factor is and essentially divide it out. So looking at the numbers here, what's the biggest thing I can divide out of 8 and 12? Okay, so now let's look at the variables. This one's x cubed, this one's just an x. So you can only take out the least amount. This one only has 1 x to give us, so that's what we're going to take out. From there, you're essentially doing the distributive property in reverse. Instead of multiplying something in, you are dividing something out. So 8 divided by 4 is 2. If I had x cubed and I took one of those x's away, now I just have x squared. It's positive, so we're going to put plus. 12 divided by 4 is 3. And we only had 1 x, and we took it off, so now there's nothing left. You can always check your work and see if when you distribute this 4x back in, you get back to the original expression. The second one here, the biggest number that we can divide out of 15 and 25 would be 5. And then looking at the variables, we have x squared y and x squared. So since these both have an x squared on there, we can take that out. But since this doesn't have a y, we can't do anything with the variable y. So 15 divided by 5 is 3. And like I said, if I have x squared y and I take the x squared off, I'm just left with y. On the second term here, 25 divided by 5 is positive 5. X squared, I take off that x squared, so then there's nothing left there. On this last one, we have 8x squared plus 32x plus 16. So looking at the numbers, the biggest thing that I can take out of 8, 32, and 16 is an 8. And then for the variables, we have x squared, x, nothing. Because this 16 doesn't have any x's to give us, we can't take it out. You can't take something that's not there. So 8x squared divided by 8 is just x squared. Positive 32x divided by 8 is positive 4x. And 16 divided by 8 is